right, welcome back to this series on implementing some of the basic sorting algorithms in Python. Like I mentioned in the first video, if you're anything like me, you can read about this stuff, watch videos, feel like you get it, but if you're not actually getting your hands on the keyboard and doing it, it's easy to think you get it and not realize the gaps in your understanding. So I'm making these videos mostly for myself to go through this process and make sure I really understand everything, but also to walk anyone else through these algorithms if you're kind of in a similar situation. So with that being said, let's talk about merge sort. Uh, the idea with merge sort is that if you're able to find some recursive way to break apart a problem and apply the same solution to each of these broken up parts, you can often make solutions quite a bit easier. So rather than talking about it in the abstract, let's just give a real world example. So let's say we have a list of numbers and it is 5, 7, 12, 1, 6, 5, and 8. And so rather than working on this whole list, if we can come up with a way to, and actually I made that 7 numbers, let's make it 8 numbers. Let's add 10 here. If we can find a way to break apart these 4 from these 4, um, and so now we've got 5, 7, 12, 1, and then break apart these 2 from these 2, and so we've got 5, 7, and 12, 1, and then even break apart this one from this one, so we've got 5 and 7, right? If we can go all the way down this chain, breaking them apart, and then we can come up with some efficient algorithm for taking the two parts and merging them back together in the correct order. We can do that process. We can break them apart all the way down the chain, and then we can do that process all the way back up the chain to put us back to this full list, but all in sorted order, right? So rather than needing to sort every number relative to every other number, we can do this in these smaller groups, merge together the smaller groups with some extra efficiency, and end up with the full list sorted. Uh, so let's look at how to do that. If we So we want to have a function merge sort, and let's take in an array. Actually, let's call that items, and the lower index, and actually, you know what? Let's just take in the items, and then we're gonna have low index be 0 because we obviously want to start right at the bottom, and the high index be the length of items minus 1. And what we want to do, remember, we want to break this apart into that smallest problem, and then we want to be able to merge them back together, right? So we're going to want to both repeatedly call merge sort, where we're calling it on that smaller and smaller batch, right? So if we say we want to call merge sort, you know what? We actually are going to need to, we don't want to define the low and high index in here because when we call it on the pieces, um, those are going to have different low and high indexes. So let's say low index and high index are part of when you're calling it. Um, and what we're going to want to do is continue to call this all the way down to the point where the low index is the high index, right? Where we break down to that smallest fragment where there's no sorting to do at all or no more merging to do because it's just one number. So what we want to do is think about if low index is less than high index, we could probably just say here, if low index doesn't equal high index, but let's do this just to be safe. Um, and then we want to calculate the middle index. And of course, we can do that by adding the two indexes together and dividing by 2. That'll find us the middle point. So we can say high index plus low index divided by 2. And then let's make sure that's an integer. Great. And so once we have that midpoint, we're able to start this recursion, right? And then we can think of this as kind of moving down the tree to break it apart into these smallest problems. So we want to start by calling merge sort on the first half. So we can do that with from the low to the middle. And then we want to do it again on the second half from the middle plus 1 to the high. So if we just did this, think about what we're doing. We are actually, you know what? Let's do it this way. Um, we can say print items, and then let's import random and make the data is random.randint from 1 to 100 for I in range 10. So we're going to get 10 random numbers, and we can now call merge sort on those numbers. And remember, we haven't done any sorting yet. All we're doing is saying, let's break this apart into the smallest possible problem. So let's run this. And we obviously needed the low and high. So from a list of 10 numbers, we want to go from 0 to 9. No, we want to call it print from low index to high index. So that's printing the range that we are dealing with in this level of the algorithm, because we're passing the entire list across every time. We're just breaking apart the ranges that we're going to be calling. And let's actually say print data once. All right, so we've got these numbers. And index plus 1. There we go, making this hard on myself. So you can see what's happening here, right? We've got these, and let's make this 8. So it divides evenly. We'll make that 7 to go along with it. And there we go. So we've got these 8 numbers, right? 17, 23, 70, 63, all the way across. And then we're going all the way down the chain. So we end up at the bottom of the chain with just 17 and just 23, and then the merge of those two. And just 70 and 63 and the merge of those two, and then the merge of those 4. And then same thing on the other side of the tree, 58 and 51, and the merge of those two, and the merge, and then the big merge at the end, right? So this is already doing what we want in terms of recursively moving all the way down to the very bottom, because you can see what's happening here is we're calling merge sort, and before it even gets to this print line, right, the first merge sort that was called is actually this one that's returning the entire row. But it doesn't get there for a long time because we're calling merge sort. It's, yes, low index is lower than high index. We're calculating the middle, and then we're calling this merge sort, right? We're calling this one a 4. But again, it goes into it, and low index is lower than the high index because it's going all the way from 0 to 3, or from 1 to 4. And so again, then it's calling it, right? And then it's calling this one, and then it's calling this one. And finally, when it calls this one that's just 17, low index isn't lower, and therefore it prints. And so we're done. And then it pops back out and goes to the next leaf of the tree, and it does 23. And then now that both of those are done, we're finally done this if statement in this larger one that was 17 and 23, and it's allowed to print. So this algorithm already is doing that recursive function all the way down the tree, printing from the bottom and then bubbling up to the top. The problem, of course, is that it's not doing any merging. Right? It's just breaking it apart and then putting it back together. And you can see that we have the exact same list at the bottom. So what do we need to change here? We need to build a function merge that is going to take in the items, take in the low index, take in the middle index, take in the high index, that basically can then take 2 different lists that are passed to it, right? The list of things up to the middle index and the list of things from the middle to the high. So it's going to take those 2 ranges and figure out how to merge them together and put them back in place in the main master list in a way that actually makes sense and is in order. So what we need to do then is write that function. So let's do that. And one of the downsides of merge sort is that it takes some extra memory to do, right? We can, as far as I know, do that sorting in place. We need to have a buffer or some temporary other place to put these lists so that then we can sort the original list. So let's make buffer 1 and buffer 2, and these are going to represent the list of lower items in order, the list of higher items in order, and then in place in the original list, we're going to put them in the merged order that's actually correct. So let's fill those buffers up. So from low index to, we want it to go all the way to the middle index. So the middle index plus 1, and we can do buffer1 dot append items I. Is that right? Yes. Okay. So we're saying from the low index to the middle index, let's take this buffer and fill it with the numbers that are in those positions, and then let's do the same thing for the middle index plus 1 up to the highest numbers. That'll be the high index plus 1, and exact same thing. Okay. So now if we want to test this, buffer1, just to show where we are, let's comment that out, and let's just call merge on, yeah, let's do this. Uncomment this one, and we'll call merge on the data with the low index of what? 0, middle index of 4, high index of, I guess this should be 3. So here we can see exactly what it's doing. There's the full list, and it's making buffer1 with the first half and buffer2 with the second half. So now we have these temporary buffers, and let's create. So here's where all the benefit of merge sort comes from, right? Is that because we've done this recursively and we're coming back from the bottom to the top, each of these two buffers will be in order, right? They'll be sorted already. And so rather than needing to search through all of them, how would you merge two sorted buffers? Well, you can take the lowest element of each and compare them. Whichever one is lowest, that's the first element of the new sorted buffer. And then we can take it off of those two lists and then compare the new smallest elements from each and continue doing that until there's none left, right? And so let's set I as the low index because we're going to want to put these right back in place in the items list and say while buffer1 or actually, you know what? So we want to do this while buffer1 or buffer2 still have anything left in them. But we're going to be comparing the top elements, and if either one of them is gone, I don't think that comparison will work. So we might have to do a few separate loops. So we'll do buffer1 and buffer2 and say, okay, let's say if the first element of buffer1 is less than or equal to the first element of buffer2, then we want items I in that index spot, the low index, right? Because it's going to be the lowest element of either of those buffers to equal buffer1 dot pop 0. And then we want to increment I by 1. Otherwise, we want to take it from the other list, right? We want items I to equal buffer2 dot pop 0. And I actually am not sure if pop is a efficient way to do this. It might be actually sabotaging the benefit of this entire thing. I know this is generally better for linked lists and data structures like that, where it's not as easy to pop in it at different elements. But for me, the main purpose of this is to really understand the mechanics of what's happening. So I'm okay if this isn't the most efficient. And so that'll run until one of the buffers runs out. And then we're left with one remaining buffer where we want to just go through all the items and add them back and continue to increment I. So we can just test one of them. Say while buffer1 items I equals buffer1 dot pop 0, I plus equals 1. And alternatively, while buffer2 items I equals buffer2 dot pop 0, and I plus equals 1. And I think that should be it, right? So we are pushing down recursively to the bottom of the list. From that bottom, right, the first, we saw it when we called this, the first one that's going to make it past those merge sorts is just 17 on its own. Well, merge this full list of items from the low index, which would be 0, right? For 17, it's index 0. Mid index 0, high index 0. Well, we know with all that, all it's going to do is put 17 back in position 0, right? And then it's going to do it for 23, and it's going to put it back in position 0. And now we pop up to this round where it looked at 17 and 23. And finally, there's something useful to do, right? The low index is 0, the high index is 1. And so we're going to have two little buffers, 17 and 23, and it's going to do this comparison. Which one is lower? It's going to put that one in the first position. In this case, 17 will go back there. Then buffer 1 will be empty, and it'll go to buffer 2. and it'll just take that. So now we have 17 and 23 in order. And then again, 70 will do nothing, 63 will do nothing. And then these two will go back into merge sort again, and we'll have buffer 1 will be just 70, buffer 2 will be just 63, and it'll do this comparison, and it'll put 63 first. And then the fun stuff starts, right, where it's merging the 17 and 23 with the 60 plus 63 plus 70, and it's going to go through the same process. It's going to say, okay, the top element of each. What's the 70 or 17 or 63? And 17 is lower, so we'll put that in position 1. And now it'll say 23 or 63. 23 is lower, put that in position 1. And then we'll jump down to do the rest of buffer 2. So this should work completely as is. And what we'll do is we'll print the data, we'll sort it, and then we'll print the data again, because we're not returning any values, we're just sorting it in place. And there we go. So we started with a list that's unordered. We finished with a list that is in order, and we can crank that up to, say, 100 elements and 99. And that should work totally fine. So we've got this new list that's in order. So that is merge sort. It can be a little hard to get your head around anything recursive, because there's something about that kind of moving down the tree and moving back up that can feel a little complicated. But obviously, in terms of actual code, quite a bit simpler than heap sort or some of the other ones we're looking at. If you have any questions, ideas, things I got wrong, I would love to hear them. Otherwise, I'll see you in the next video.